All right, well, welcome everybody. We're super excited for this session on AI and the recycled materials industry. We got a great panel lined up for you tonight. Finally, would like to thank our sponsors for this event, the ISRI Young Executive Committee, for bringing this together. Obviously, AI is a super hot topic in a multitude of industries, and we're really excited to be bringing you some presentations on how it's going to impact your business day to day. So we'll get the slides up here, please. All right. So to kick things off, just a quick agenda. I want to talk about first, why are we here? Why are we even having this presentation? Moving into a brief history of AI, how it's evolved, especially over the past few years. There's been a lot of movement on a multitude of dimensions. And then ultimately, what does this mean for my business? What can it do for me? And we have a couple of demonstrations that we're excited to walk you through, just so that you can see what the impact's going to be for the recycling industry. And then we're going to finish with a panel discussion with a few of the experts in AI here. So kicking things off, like why are we here to begin with? So generative AI has advanced radically over the last 5 to 10 years, and the investment in the platforms and the processes to make this happen have been occurring really over the past 5 years in summary. So we put together a panel of folks who are founders of different AI companies from consulting to consumer products, and wanted to kick it off by having you guys introduce yourself first. So we'll start first with you, Sid.
Sure. So my name's Sid Grover. I founded and run an investment company called Canterbury Lane, focused on the energy, mining, and metal space. One of the key sectors we're focused on is metallurgical coal. So we are adjacently involved in the steel value chain. Met coal is used to make steel. So, we own, operate, and manage met coal assets, and that's our involvement in the steel industry.
Awesome.
I'm Dennis, and I'm one of the founders of this company called Adaptive Computer. And before that, I founded another company called Mem.ai. We ended up raising about $30 million, and OpenAI, the creator of ChatGPT, was our lead investor in the Series A. And so been working in and around AI, primarily, working software for the last 4 or 5 years.
Hey there, I'm Josh Singer. I'm one of the founders of Eigen. We're an AI holding company. We do a number of different things, but most relevant for ISRI is we work with Fortune 1000 companies and PE firms to help define and execute on their AI strategy. So we try to stay on the cutting edge. We do a lot of work in document processing, which is very relevant for the workflows that the recycling industry focuses on. So I'm excited to talk to you.
Awesome. Yeah, thank you so much for joining us. And my name is Hougo. I'm one of the co-founders of ReMatter. We're a software company that provides scale ticketing, inventory, and sales software for the scrap metal recycling industry. So let's dive into it. AI is everywhere, but what actually is it? So why don't I start it off, a little bit interactive here. How many people in the audience have heard of ChatGPT, just by a show of hands? Okay, a lot of folks. What about Microsoft Copilot? Anybody? They had a Super Bowl ad earlier this year. And then Gemini. Anybody on that? Okay, cool. All right, so a lot of you have been seeing more and more of these consumer AI products that are coming out. And what we're seeing too is AI is becoming more popular. It's touching so many different parts of our life. Obviously, AWS, Amazon Web Services, is one of the big sponsors of Thursday Night Football. If you watch football, I'm sure you see they have all the different stat casts and things where they're using these AI models to essentially predict things that are going on in sports. So it's this marriage of data with, the different technologies that have happened over the past few years. More recently with OpenAI, ChatGPT, you've been seeing tools like DALL-E or Sora that are being used more for entertainment purposes. So, even some of the marketing teams of different scrap companies we see are using generative AI to produce images for their marketing collateral, and it's going to continue to be more popular in movies, social media, et cetera, going forward. So, I guess a couple of things, and Josh, I'll turn it over to you. The AI has evolved a ton in meaning over the past few years, and I'm curious for your perspective on how that shifted.
Yeah, I think there's kind of 2 different periods of AI, and distinguishing them is really important. The first is in an era of 2017, 2018, where computer vision advanced a lot. So we started seeing technologies like self-driving cars come out from companies like Tesla and Google. But in the past 2 years, we've experienced such a Cambrian explosion of new technology in this space called generative AI, which basically means AI isn't necessarily just classifying the work, but it's doing the work. It's able to write copy. It's able to solve tasks in a way that humans do comparably. So there's a lot of opportunity here, and it's just really exciting overall.
Awesome. Yeah, so quick things before we dive into the demos and everything. Brief history of AI. AI was coined quite a long time ago. In the 1960s, really came out of research projects primarily in universities, and it's gone through a couple of valleys and peaks that really relate to stepwise jumps in the hardware that's needed to support this, along with different investment. And as Josh was saying, in 2017, we've really sort of hit this like third wave of generative AI, where we're able to produce copy, images, all this different things, and we're right on the forefront of what that's looking like. The other sort of trend that's happening in the background is private investment from private equity, venture capital has drastically increased in the early 2020s, and it's going to continue to be a record year. Obviously, the stats aren't out for 2024, but based on the different companies, valuations being funded, it's going to be pretty tremendous growth in terms of the money going into the industry. And I think for a lot of consumers and us as users of smartphones and apps, really AI has shifted from research-based to actual consumer products. So some of the early AIs, things like Deep Blue, where you have a computer playing chess against a grandmaster in chess, or Go, and then moving to things like Face ID and other tools that we use each and every day. Ultimately, what's been fueling this growth, though, over the past few years has been the increase in compute power. So for anyone in the audience who owns NVIDIA stock, you've probably been very happy to see your earnings over the past few years. NVIDIA is on the cutting edge of microchip processing, and essentially we're orders of magnitude higher than we were 2 years ago in terms of our ability to compute. And ultimately, underlying all of the AI is the hardware devices. I don't know if you guys have anything you want to add on that. Cool. Keep charging on. All right, so what can AI do for me? So there's a few consumer products, obviously some that are relevant to your business. So things like document processing, content creation, weather forecasting, things that you're doing each and every day. But specific to the recycled materials industry, there's a number of categories that primarily involve humans processing documents, helping out customers, managing customers, and AI can help facilitate and aid in a number of those different dimensions. So there's really 4 demos that we wanted to talk through today before we get to the panel itself. So the first is material identification, license plate identification. Both of those are under the umbrella of computer vision. So essentially what we're doing is we're using cameras to identify material that's placed on a scale, identify material in the back of a roll-off truck that's pulling up. If you've gone through a parking garage, and as an example, and prepaid for parking, it scans your license plate and is able to open the gate and let you right through. So we'll talk a little bit about that. The third is data exploration. So obviously, all of your businesses are sitting on a history of financial data, material data, pricing data, and unless you have someone who knows like Tableau or Microsoft BI on your team, you might not have access to the dashboarding or reports that you'd want to see for a business. And the final one, which I'm really excited to get to, is phone agents. How do we scale customer support while providing great service? So let's talk first about material and license plate identification. So the underlying technology is computer vision. I guess just starting off, like, what is computer vision, and at a high level, how does it work?
Yeah, so computer vision is, put simply, it's the task of taking an image and being able to discern something from it. A classic example is, given a picture of a cat, is it a cat or is it not a cat, right? That's the classic computer vision case you saw in 2017, but it can get way more advanced than that, such as extracting individual fields from PDFs and doing things like license plate recognition.
Perfect. So the first one that we were going to talk about is material identification. So what you can see over here on the left-hand side, probably a pretty common scene at your yard here. You have a peddler or someone at your facility unloading a wheelbarrow or unloading from the back of a truck and putting material straight onto a scale. From talking to a lot of folks in industry, obviously you have pretty big commodity libraries. You have to train different users with various levels of tenure on exactly what material it is. But a lot of yards who we see working with and throughout the industry have cameras that are sitting over those scales themselves. A model can be trained to identify material. So what you're looking at right here is some electric motors that were placed on a non-ferrous scale. Essentially, with a camera and with the right compute running in the background, you can essentially trace a bounding box on the material. So that's that yellow square that you see, and assign a confidence interval of what that material is. So the implications of this are scale operators who might not know all the different materials or commodities. You could essentially suggest what the material is, or cross-reference the material that they selected versus what the computer model thinks that it is. So I don't know if you guys have anything to add about this demo specifically.
Yeah, I mean, I think one of the really interesting things that's happened recently here is we used to have just like very highly specialized models for every specific task, right? So there would be a model that was just trained on whether or not it can detect dogs or cats, and then a separate model that probably just for these types of materials, and then you would have a separate model that was for language or text prediction. And one of the really interesting things that's been happening is kind of all of these models, you might have heard the term multimodal model before. It was kind of consolidating under one roof, and there's some really interesting things that kind of happen as a result of that frame, which enable a lot of user space at big design.
Perfect. And the next sort of computer vision, demo and workflow I want to talk through is license plate identification. So this is probably one that, again, a lot of you have had experience with. You pull into a parking garage, you prepaid for parking at the airport or wherever you may be. Typically, there will be a low camera that's lighted or in the back that's capturing a photo of your license plate. It's essentially parsing out the letters and numbers that are on top of it, and then it's taking an action. So in the case of a parking garage, it's just opening up the parking meter and allowing you to pass through. This technology has been around for a little while, but it hasn't necessarily been applied to the scrap industry. And there's a few different use cases of it in the industry specifically. A lot of folks, when a truck pulls up onto the scale, whether it's a commercial account or public, you're capturing license plate data that's associated with that account. So essentially what you can do is trigger the opening of a purchase receipt or of a sale ticket that's going out purely based off of the license plate. And that enables a couple things. If you think about the future, could you run a fully autonomous scale house? One of the only ways that you would be able to do that is to get there through license plate identification. We need some way to associate the transaction to the account that we're buying from. And ultimately, if you have the details stored in a strong system of record, you're able to pull it up and set up automated workflows through there. So kind of similar process to materials. I guess, though, how do you differentiate between, obviously identifying materials, which are super varied, and license plates, which are pretty standardized across, vehicles? Like a state only has, a few different variations of the license plate.
Yeah, so you would probably use two different kinds of models. One that was maybe specialized in license plate detection, and that can be cheaper, faster, and work better for that specific task. And for something that's as varied as materials analysis, you might use a general purpose pre-trained large model like the ones that OpenAI is producing, like GPT-4.
Perfect. Cool. So the next demo we want to move on to is data exploration. So the underlying technology for this is a large language model, or an LLM. And it'd be awesome to have you guys explain what an LLM is.
Yeah, sure. I mean, an LLM is fundamentally, it's very simple. Basically all it's doing is, given a series of words, all it's doing currently is it's predicting the next word that should come from that series of words. And it does it basically just through massive amounts of matrix multiplication. So it's a lot of math that's happening. But fundamentally, it's actually very simple, and it's just kind of a lot of the same math that's happening over and over again. It's predicting the next token after it gets that, and it predicts the next word, and then the next word, and so on and so forth.
Cool. So the idea of this demo is, all day long, you're asking your operators or your buyers or your finance people, hey, how much money did we make last month? How many materials did we purchase? In our day-to-day lives, we interact through, text, through voice. And the idea of, a system like this is essentially you would be able to prompt a system, hey, show me my top purchases in the last 30 days. A question that different people are asking. Underneath the hood of, any sort of system of record, you can essentially, with using these large language models like ChatGPT and other APIs, essentially write the SQL code that's going to be able to give you the data that you want. So simply put, think of it as you being able to house all this data, and instead of having to have all these saved reports and stuff, you can essentially prompt your data and it'll return a response with the different results that you're looking for. So obviously this is a table, so it's pretty static, not super interesting. However, what's also cool about this model is you can create different visualizations on top of it as well. So you have this mix of, sort of like flat file data, but also graphs and visualizations that sit on top of it. And then finally, in the demo, I'm really excited to show everybody is voice interaction. So especially, retaining employees, training employees is always an ongoing battle, and constantly looking for ways to do more with less. And we've all had somewhat some interaction with a voice in one shape or form. You call an airline trying to change your flight, it sort of passes you down a different phone tree. These same technologies can be applied to your business and the recycling industry. So let's talk a little bit about speech to text. Like, how is it working under the hood?
So basically what is happening is there's a few different models that are being used. The first part is we get the phone audio data, and we, as in the computer system, get the phone audio data and go from speech to text. So we're able to get the words, that's a transcription for that audio data of the call. Then we put that into a large language model, which Dennis did a great job of explaining, that's able to determine what to say next in response to the person that's calling on the phone. So we have that, basically we have the words that the computer is supposed to say, and then we put that through a third model called the text-to-speech model, which will create a Siri-like voice to say those words. And so basically that three-pronged system of going speech to text, think about what to say, text to speech is all that's happening under the hood, but it can create some really unique, just like tech opportunities, such as voice agents.
Cool. Yeah, that's super helpful. And especially in the AI world, agents are becoming more and more of a topic, and obviously speech to text agent, is one of the things that comes up. Like, what is an agent for those who don't know, Dennis?
Yeah, I mean, if you're familiar with ChatGPT, I'm sure maybe you've also started hearing about agents and like what is this agent thing. It's actually really simple. I think people overcomplicate it. ChatGPT, you can ask essentially any question, and unlike Google, where you're given 20 blue links and then you have to figure out the answer, it actually maps the world of knowledge onto your question and provides you that personalized answer. And so all an agent is, you can kind of think about it as, instead of you having to ask that first question, what if you can use the same system that is giving you the answer to also figure out what question to ask? And then also to have that same system then be able to determine, given an objective, have I accomplished my task being? If I haven't accomplished my task, what is the next step I should take, right? So, in the context of, a phone agent system, the task will be, hey, carry on this conversation until you have successfully scheduled a job, right? And then the agent will basically at every turn of the conversation ask itself, have I scheduled a job? No. If I have not scheduled a job, given the current state of where the conversation is, what should I ask next, right? And that's fundamentally all an agent is.
Awesome. Yeah, so we'll get into it here. So, the demo that you're going to see, obviously you want to provide great support to all your commercial accounts. Might be the weekend, somebody calls in for a service for the following week, nobody's there to pick up the phone. Still want to have the ability to, keep things scheduled and progressing forward. So let me go ahead and play this here.
Hey there, this is Drake Hougo. We're really excited to show you our new conversational AI platform. So what you're looking at right now is the ReMatter Dispatch Load Board. This product is specifically used to assign jobs to drivers, telling them what bins they need to pick up and what accounts they need to service. So what our conversational AI is going to do is it's going to act in place of the dispatcher who's scheduling a job. So a supplier is going to call in, request some service, and over here on the left-hand side, we're going to create a pending service request column and job that we can then assign out to a driver. So let's go ahead and get into the demo.
Hi, this is Rockstar Scrap Metal. How may I help you?
Hey there, this is Drake from Falcon Industrial. I was just calling in for a 4-yard swap, please.
Hey, Drake, nice to hear from you. Could you let me know which location we'll be servicing for Falcon Industrial?
Yeah, I live at our headquarters location. We're at 300 Coleman Drive in San Bruno, California.
Got it, 300 Copeland Drive in San Bruno. What's the best time for us to come by for that 40-yard swap?
Yeah, best time is Friday morning at 9 a.m.
Friday morning at 9 sounds good. Just to confirm, you need a 40-yard bin swap at Falcon Industrial's headquarters at 300 Copeland Drive in San Bruno, right?
Yep, that's correct.
One moment while I set that up for you. All set, Drake. Your 40-yard swap at Falcon Industrial's headquarters is scheduled for Friday morning at 9. Is there anything else I can help you with today?
Nope, I'm all set. Have a great day and see you Friday.
You too, Drake. We'll see you on Friday. Have a great day.
Awesome. So the conversational AI demo just wrapped up. So if we jump back now to the ReMatter load board, and it refreshes. I can immediately see in this pending service request column, we have an exchange of Falcon Industrial. To go ahead and click into the job, and all the core details from that phone call conversation come in here. So we know the company name, the location and the address, which we've queried from the database, and then we know we're picking up and dropping off a 40-yard bin. So we're very excited to show you, what the future of work looks like in the scrap industry.
Awesome. Okay, so yeah, obviously just a demonstration on the potential applications of what this can look like going forward. There's obviously a lot going on under the hood here. We're essentially having to parse out somebody calling in, decoding, understanding what they're saying, and figuring out how to respond. Like how is it actually working? Just saying that demo.
Well, first off, there has to be a great system of record in place in order to be able to store that data and make actionable items. So a platform like ReMatter, you need to be able to store that info and also retrieve that info over the course of the conversation, because relevant details might pop up. For example, maybe someone isn't available to be around for the job at the time. So that's like the first assumption. But what's kind of just going on there is, again, it's this speech to text, computer thinking, text to speech interaction. And then paired with a very powerful system record, you can create really phenomenal experiences. And one thing I want to add too is that voice agents don't necessarily even need to replace your existing workforce. They can be purely like an augmentation of your talent team. So for example, there may be periods where you have of seasonality where there's higher demand and you don't have enough people to take in calls. You can spin up voice agents. What if you get calls in the middle of the night and no one's staff? You can have voice agents. So it's not purely replacement of people, but it's working side by side along people so that you can service the demand better and you're always ready for new opportunities in your business.
Awesome. Perfect. Well, we're going to move to the discussion part of the panel now. We just want to run through briefly what AI is about, a few different applications of it, and mostly want to focus on the work that these folks have done. So one of the key topics that again is pretty relevant in the scrap industry is document processing. For those of you who run yards, probably have fairly large back offices where paper is constantly flying around, email, fax, ingesting different data and information. And Josh, starting with you, you've done a lot of work in document processing. What's kind of been the evolution of it, and where do you see document processing going?
Yeah, it originally started with the U.S. mail system and being able to determine, given a letter, what address is being written on the envelope and being able to send that to the right place. And we've gone to the point where, as of the last few months, past 6 months, we can take unstructured PDFs of things like invoices, say a ticket from a steel mill, a variety of different documents, and parse out all the different things from those images that need to get stored in a spreadsheet, or better yet, a system of record like ReMatter. So for example, what is the price of the job? When is it scheduled? And so now that can be done on the fly with the right tools in tech.
Got it. And yeah, you mentioned different types of documents. Obviously, especially as businesses transact, everybody kind of has their own form, of doing things. Some are handwritten, some are generated by computer. Prices, materials, everything is in a different place. Like, how are these models good enough where they're able to parse out that information? And what does it require on behalf of people who are utilizing these technologies?
Yeah, it's a great question. So really what allows these models to be able to take, written forms and unstructured PDFs and from a variety of different vendors and be able to do it all under one model is just the sheer amount of compute that has been spent by these large language model companies in training the model. So basically, computers have done trillions of calculations to be able to learn, what does this mean in this PDF? Now, as a consumer of these technologies, say you have, for your firm or your company, you're receiving accounts payable or you're receiving tickets, and you want to help either a team member or replace that team member so they don't have to manually go in and extract every detail. Usually it's, pairing with a good system of record and having and using like one of the third-party large language models, and they can do a pretty good job out of the box if you set some parameters like, these are the 100 types of documents we get, and then usually they can take it from there.
Yeah, for sure. And I think one concern some folks might have is it accurate? And obviously computers make mistakes. Like, how do I know that my data is correct? How do I know it's not hallucinating data or mislabeling things? And sort of what do people need to be aware of, or like what guardrails are in place to help prevent that?
Yeah, this is a great question. So it's something we deal with when we're working with companies all the time is how can I trust the computer? I can reprimand, an employee. I can't really reprimand a computer, and I can't, necessarily give it the feedback it needs to improve. The way we think about it is having good calibrated systems and working with partners that implement AI tools with good calibrated systems. So what that means is usually for every single prediction from an AI model, you can figure out how likely that prediction is, how confident the model is in that prediction, right? So I can say, if I'm looking at a picture of a cat and I see it, I could say, oh, I'm 90% confident it's a picture of a cat, and my prediction's a picture of a cat, versus a 30% or a 52% confidence. You still think that, that's the end prediction. So the idea is basically like having well-calibrated systems can reduce the, hallucinations. Now, basically, all these models will suffer from hallucinations from time to time, but over the long term, they'll actually do, in benchmarks, they do comparatively better than humans. So you're actually getting a performance bonus, not just a cost savings.
Yeah, totally. And I think the confidence piece is really important when it comes to all these different predictions. And when we showed the material and sort of that yellow rectangle that was around it, it's a little hard to see up on the screen, but there was essentially a percentage. I think it said like 76% confidence. Like what does that mean, and how should someone interpret, essentially a confidence interval?
Yeah, so if a model is like deciding something, right, it's actually not, the decision is the last step. Usually it has like 15 different things it can choose from, and there's a score associated with each decision. And it usually chooses the max score in making its decision. But model providers and technologists can see the underlying scores so they can figure out how confident the model is in its prediction. So for example, if the model is somewhat confident, but it's max, it still is able to make a best prediction, you might want to send that to a human rather than a computer. So as long as you understand how confident the model is, you can be sure that you're going to reduce hallucinations, and you're not going to end up with situations where your computer is saying things or deciding on things that it's not confident.
Yeah, and I guess the sort of final bit on document processing. What do companies need to be doing now essentially to prepare for what the advances are going to be 2 to 3 years down the line?
It's such a good question. It's something we see a lot. And the big thing is instrumenting your company with good technologies such that these AI models can be utilized. So what does that mean, right? That means working with a good system of record such that everything is digitized, things are easily extractable. Platforms like ReMatter or the Microsoft suite are great examples of system of records that people use that can take advantage of these AI technologies. If everything's in handwriting, everything's done on different sticky notes, unfortunately, you won't be able to take advantage of all the new stuff that's happening. And so that's like the most important thing that you do in the next kind of 1 to 2 years. And every single company we work with, for example, HVAC companies, a lot of them do things handwritten. And the first step is, okay, we got to get you into a digital platform. Your data has to be secured, and it has to be a solid system of record before we do any of the cool AI stuff that save you a ton of money or increase your revenue significantly.
Awesome. Yeah, that's super helpful. And shifting the topic a little bit and moving to you, Dennis. So obviously, yeah, that demonstration, of, somebody calling in and essentially an AI agent, taking the phone call, creating a job and stuff, it can be a little bit jarring and certainly, frighten people, what's going to happen in certain jobs. In your work and what you're seeing, like where do you really see the interplay of the AI, augmenting jobs that are already being done versus fully taking on the work and responsibility of them?
Yeah, I mean, this is kind of the age-old question of technology and like kind of every significant advancement in technology that we've seen throughout history, really. We've always kind of seen both things happen. We've always seen certain jobs kind of become, obsolete. No one walks 2 hours to the well anymore, and then, takes water out of the well and then brings it back. But we also always see new jobs that we couldn't actually anticipate existing before popping up, right? And I think I don't really think there's any reason to be able at this time to be. For example, and what we do, a lot of what we're doing is essentially taking a task that typically a software engineer would do, and then we're building an autonomous system to actually produce software instead of a human producing software for you. So there's a human in the loop and the human kind of becomes like this taste connector, right? Where they go, oh, I want this to happen. I want this feature to exist. I want this button to work in this way, etc. And you kind of start to realize that the more you think about it, so that job in particular is actually not a job that existed even 2 years ago, right? But many of the things where let's say you had entry-level engineers who would go and take a ticket off in Jira or whatever task system and then just execute that ticket. A lot of those things are going away, right? But I think on net at the end of the day, it's going to be pretty clear that this is going to create more jobs, more opportunities out of it than the limits.
Got it. Yeah, it almost sounds like the people who are writing the code are, more at risk of, their jobs being taken away by generative AI than, any sort of customer-facing job.
I think that's been the really interesting thing with all of this, right? Which is that most people thought that automation and AI would come for kind of, like blue-collar jobs first, right? But actually, it's definitely come for, people who are actually, writing code or sitting at desks all day, and that's been like a really interesting thing that's happened.
Got it. So yeah, like data jobs, financial analysts, and engineering and stuff. And like, what do we think that timeline looks like? Where you can, let's say you needed a simple application for your business, but you're not technical, you don't know how to code, what you need, you have the data to the point where you could essentially go and essentially ask a computer for something, and it does it for you.
So if you know what you want. And if you have a really good idea of that, I think we're about 12 to 18 months away from getting most, unless it is like a hyper complex thing. But the reality is, if you think about most software are actually just a very simple set of things, but constructed and kind of, molded in different ways on top of each other. Right? But the actions are mostly just, retrieving information from a database, writing that information back to the database, maybe running a few algorithms out of that. But ultimately, it's actually not that complicated to the west part. There's some stuff.
Yeah, that's super interesting. Yeah, and it's a good perspective too. We've said system of record a bunch of times, and relevant to the recycling industry. It's essentially a bunch of tables in a database that store things like customers, materials, sales. Like, it's really fairly simple under the hood, and it's interesting to hear that individuals who aren't necessarily technical are just going to be able to spin up these applications for their business pretty quickly. That's awesome. And Sid, moving over to you. For those who aren't here for the intros, Sid has really focused on energy and mining. Where do you see different AI applications in that space?
Yeah, sure. So I'd say that they broadly fall into two buckets. One is reducing costs and improving efficiencies in your existing processes in your business. The examples in the demo are great examples of this, like processing invoices, creating and managing dispatch orders, materials identification, classifications, things that are already being done, but you use AI to do them faster, more accurately, and more efficiently. And sometimes things like this seem gimmicky or cute, but they can really move the needle when you're, taking something that's done hundreds or thousands of times in a month or a week, and you do it a little bit faster. That adds up. Like, for example, we own a mine in West Virginia where, because of rail constraints, some of the coal needs to be trucked to different coal washing plants. And the roads are narrow, and there are just bottlenecks on the number of trucks that can be lined up. So if we're able to do license plate identification and process those invoices and BOLs faster, we're able to increase utilization on a fixed number of trucks that we have, which reduces costs and increases profits across the business. So that's the first bucket. It's like improving operations that already exist. And then the second bucket, I would say, is improving the quality of the business decisions that you're making. When you're capturing all of this data, you think about some of the problems and decisions that you're making on a day-to-day basis when you're running a hard asset company. Like, which raw materials should you procure? How should you procure them? Which of your logistics assets should you use to get them to your facilities? Which facilities should you move them to? What should you upgrade them to? Which quality specs should you try to upgrade them to? And then once you have the finished products, who do you sell them to and at what price, right? And those are the kinds of decisions where you can use AI to actually make decisions better. And these are two different kinds of problems, and they're both very important, and they can both drive improvements across the business. But there's one point that Josh made earlier that I want to underscore, which is that the important foundation for all of this is having the right software layer handling the basic stuff. Processing invoices, managing dispatch orders, inventory management. Because at the end of the day, AI, like everything else, it's garbage in, garbage out. And if the software and technology that you're using doesn't have clean, accurate, up-to-date information about the business, then the decisions that the AI models make are going to be bad because they're made on the basis of bad information. So I think, the first thing that someone who wants to bring AI into their business, into their hard asset business, like a steel recycling plant, needs to do is make sure that the software under the hood works really well and has clean data, works properly, and then all of this can be built on top of it.
That's awesome. Super helpful. The anecdote about the mine in West Virginia is very interesting. I don't know if you have any other examples, in the energy or mining sector of, companies that have adopted AI and sort of what their journey was through that.
Yeah, sure. So, that's maybe an example of the first bucket, right? Operational improvements. You can, an example of, making better decisions, something that traditional steel mills, like blast furnace steel mills that make steel by reducing iron or using coke, need to figure out is, what coking coal should they use? How should they prepare the coke and their coke battery? And then what iron ore should they use that coke with? And it's similar to the decisions a lot of you folks may make around what raw materials should I get, what can I do with them, and what should I sell the finished product for? And what some steel mills have done is they've introduced AI to optimize how they match up their iron ore resources with the coal that they use. And when they do that, they're able to, they hold inventory on their books for shorter periods of time. That frees up working capital. Their business runs faster. They are less at risk of facing supply chain risks and issues. And so they're making better decisions on the basis of the data that they're gathering and AI models that they've trained.
That's great. Perfect. Yeah. Thanks for sharing about that. Here we have about 7 minutes left here during the session. So definitely wanted to open it up to, any crowd questions and stuff. I think we have a few different microphones hanging around there. So, definitely have some more questions can ask, but wanted to give some folks in the audience opportunity to ask them.
Well, I have to walk all the way.
No, go for it.
I think one of the biggest things that your point about garbage in, garbage out, it's really important to understand because a lot of people listening to us see but saying AI, cool, I'm going to put it in, it's going to be statement. But as we all know, supplier lists that are out in the records, 10, 20 years to say that, all of a sudden, safety can imagine using. So, number one, that's good to speed up the staff. And the other part is really more this abstract, nearly 5 levels. It's kind of this mission that sort of the examples. I think the other day, maybe I could be out there, I guess, what you guys, Jefferson, that don't use of stuff are using both big at, potential raw or potential DDoS type thing that some people that's in the loud. I can, call it and say, I want 30, take up 5 days, something inside that. Your hollers are all over the place. And you guys kind of word deep with that I don't want to call it ethical code, but that mentality is that, but it's a conversation stuff. Jason?
Yeah, that's a great question. And, with any new technology, there's good actors and there's bad actors. And there's places that can be ripe for exploitation, but there's also places you can patch. And so I'm really glad you brought up that question and that point. And it brings me to a larger point, which is, well, first off, how do you solve that, right? What is that attack called? That's called a prompt injection attack, where basically you recognize there's an AI under the hood and you say certain things to get the AI to respond in a way that one of your human teammates would not. And so basically you're trying to trick the AI. And so what you can do to mitigate that is you can have a set of checks in your underlying technology provider to make sure that the data that they end up recording from that conversation meets certain basically guidelines or basically criteria. So for example, you would never have more than 5 loads in a certain period of time, or if this is an unknown caller that you've never heard from, you might not accept that immediately and it might be put into a queue. And so what I would say is, one, it's a responsibility of the technology providers. And so you want to partner with a system of record that is very capable in implementing these new technologies and is able to create the mitigations. And 2, you're choosing the right vendor for that. Just because someone says AI doesn't mean that they've been working with AI for a long time or that they have these mitigation restrictions in place. So thinking a lot about, the technologies you're using and kind of how they're advertising, against these prompt injection attacks is both the responsibility of the consumer as well as the vendor.
It's a great question. And yeah, expanding too on the prompt injection attacks, like the way to, if you wanted to simulate what this would look like is go into ChatGPT and essentially, bully it into, doing things that it won't want. If you ask it to do something, illegal or inappropriate, it'll throw warnings and stuff up that it can't do it. But, it's an interesting experiment, like for you, literally on your phone, if you download ChatGPT to see how these, AI agents essentially respond to doing different things. The other point that Fernando brought up is, bad data in, bad data out. And it's a really salient point too, especially when, recyclers are doing, hundreds of transactions every single day, and you have repeat business, you have, duplicate accounts, you have data that's spread out across. It's an interesting point, if you have an existing body of data and you're not starting from scratch, like what can you actually be doing to, get things cleaned up and in a good spot to utilize these technologies featured out in the future?
Yeah, and I think what's actually really interesting is that that's actually one of the superpowers of this technology today, which is, so originally this technology was actually trained for a very specific purpose, which was just translating languages. So, from English to French, and French to Italian, etc. And what just so happened is that task, training on that task, ended up kind of having all of these different properties. And if you think about it, it makes a lot of sense. If you take something that is unstructured and you're trying to extract, a structured table out of it, what you're basically doing is translation. And you're taking unstructured data and you're translating. And so as long as you have the record, so, even if it's written on paper or if it's spread across, 10 different applications, there are a lot of people that, that I know of who are building these solutions now where you can actually take all of this data that's formatted differently, that's, sitting in kind of different places. You can snap, photos of them, and they can all end up in kind of the same place and in the same format, right? So I think this is something that, that people are definitely working on, and it's the technology is definitely that. Awesome.
Yeah, we'll go back to the audience. Anyone else with any other questions?
That me. Think it got the okay. Did he? No. Chỉ là kịp vâng tile up my stay and cuts then worry in the plan then it's the man in non that.
Yeah, real quick too, just repeating the question here. The question was, the line is a little bit blurry between, what's an automation and, what is AI and kind of where is that drawn together?
Yeah, and automation, at least is that how I think about it. You know, everyone loves to like use different terms for different things. This is my personal opinion is a process for which a computer does a task either partially on its own or all the way on its own. So when I think about an automation, I think, you know, we've had automations for a long time. You know, we've, you know, there's a lot of things in software that already automate the things we do. Where AI comes in is it's able to bring in some human judgment, human-like judgment into that automation process to automate things that we haven't automated before. So for example, you might have someone who, you might have a ticket that comes in and you need to transcribe all the data from that ticket to go into your system of record. Maybe the automation before was having a human go in and do that manually, and then it gets stored in the system of record, and the automation is the email that gets sent out to the supplier. Now, automations can be improved with AI such that a human doesn't have to go through the PDF line by line and transcribe that stuff. It gets sent to an AI program. That program returns the structured data and then puts it in the system of record, and the email gets sent out. So automations have existed before, they continue to exist, and AI is able to provide a new helpful component which introduces human-like judgment. Does that answer the question?
Yeah, and I think the other thing I'd say is you're right that some of the things that have been demoed here have been possible in the past. I mean, identifying license plates, you know, any of us who've gotten a driving ticket, an automated driving ticket in the mail, knows that that's been around for a while. But I think the difference is now it is a lot easier to develop these capabilities with lower resources, and also to create them, to train these models and bring them into your business as your business currently operates, rather than pigeonholing, like trying to fit the way your business operates into the mold of some product that already exists. And this is particularly relevant in industries where, you know, there aren't, there isn't a single body of quality standards, there isn't a single body of spec standards, right? And different businesses need to do the same task, but they need to map it to their own unique business context, right? And in a sense, that is an automation task that is unique to that business. And what these models make possible is a small or medium-sized business to create that, whereas 10 years ago, you would have needed to pay Accenture $5 million in order to develop some kind of a computer vision system for your business. Now, you know, someone competent can do it in a day or two using GPT. So it is the same task that was possible in the past, but now the scope of application and the scope of companies, like many of the ones that you run, that can use it and leverage it has grown a lot.
Yeah, I think another way to kind of think about this is, you know, previously you would kind of define an entire workflow of, you know, if this happens, then do this, right? And now what you're doing is you're not defining a workflow. You're saying, I'm going to give you, this AI system, these capabilities. I'm going to give you the ability to open a document and read it. I'm going to give you the ability to pass this through some transcription tool. I'm going to give you the ability to send an email to this user. And I'm going to give you all of these capabilities that if you think about, you know, what a human does on a day-to-day basis, these are all single unit support. And then you give them these capabilities, and then you say, okay, cool. Now you can use your reasoning system given a new situation to determine what action I should do next, right? So instead of, you know, having to define, you know, if you think about like all of the, especially, you know, in real highly complex businesses, all of the different if-else statements. So, you know, if this, then this, there's this kind of like too many to actually deal with, right? So it kind of shifts the complexity away from the, you know, having to predict all of the workflows that you would actually, that would have to exist, into saying, well, this is how, you know, this is what a human would be able to do. I'm just going to give you these tools, and you can decide how to use these tools. And
probably have time for, about 2 more questions here.
I mean, we deal with all sides person of this work years.
Oof. um, Look, I think if used, this is a very theoretical answer, but I think if used properly, what AI should do if it's improving operational efficiency across a business is reduce the amount of capital that needs to be tied up in that business to do whatever it does, whether it's recycling steel, whether it's producing and shipping coal, whether it's producing virgin steel. Less capital needs to be tied up in it. And so, again, I'm just thinking about this in terms of, finance theory. What that should do theoretically for these companies is lower their cost of capital. If, companies in these hard asset industries, if they need less capital to do what they're doing, and with that less capital, they're doing what they're doing better, then their cost of capital should come down. And historically, when the cost of capital has come down for industries, it has been deflationary for those industries because it makes it easier it lowers the costs of operating in that industry. It makes it easier for new players to enter and leave the industry. And the aggregate effect of that, as with automation in the past, is that costs tend to come down. And so the prices of commodities tend to come down. So for a pass-through or a spread business like a recycler or a refiner in the oil world or a treatment plant in the virgin copper world, maybe this won't be as big of a deal. But for the primary producers of these commodities, this could potentially be problematic for them if it is disproportionately deflationary to their top line versus how much their costs come down. That's the long answer I'd give with a water gun to my head. The short answer is I have no clue.
Awesome. Yeah, we got time for one or two more. Oh.
What? You can't.
Sure.
But
Yeah. Sure. So yeah, so the question was, machine company implemented an ERP system, and essentially now the net new ongoing costs of IT infrastructure is, outweighing the cost savings from implementing a new system. So yeah, I mean, you guys have done a number of these implementations. What are your thoughts?
Yeah, this is a common case when working with certain ERP partners. There's a lot of promise around business cost savings and the analytics you'll get, but you end up having both the capex of the systems, the computers in place, and also the opex of increased opex from the overall maintenance team, call it, in being able to keep this system together. Unfortunately, I can't really speak on the specific ERP system because I don't know exactly which one you're working on, but I have seen this trend. I think it's very important when you choose a system of record of ERP that, again, you choose one that has typically lower costs of maintenance or ongoing maintenance costs. And what I would also say is just because something is in a system of record doesn't mean it's necessarily easy to get out. And so, for example, you might have it stored, but it might be really hard to work with that data even though it's digitally stored. So couldn't comment unless I heard the specific ERP system because, SAP versus Oracle NetSuite versus a number of different systems, they kind of have their pros and cons. But I'm curious if you guys have ever worked with sort of large ERP system migrations or getting insights and analytics from, basically out of them in a way that over the long term decreases the cost of the business such that that initial investment results in better decisions or just overall lower operational costs.
I think my main comment on this will probably just be that I think a lot of the, if we look at when these technologies, we've been hearing about really came online, you can either say it was April of last year or November of last year, and it's one of those two periods. And, so all considered, people have had about 6 to 12 months to actually truly build on this. So basically everything you hear about right now, when, especially an incumbent says, oh, we do AI, and it's just stale. It's not action. They implemented one API call to something, and then finally they're using a person login so that they could send in. And I think over the next, 12 to 18 months is when we're really going to see these things actually come into work. And so, I think one of the things we mentioned, for example, is, you have this, even when they're not working, we're being built, right? And actually, this is, if you think about it, this is fundamentally to the promise of this new technology, because what we've actually learned to do is to convert energy into intelligence, right? There's this now this direct translation from energy and, basically doing that and then outputting useful things on the other side. And, that should be an on-demand system, right? That isn't really something that you need to be paying for consistently. You only need to pay for things when those calculations are actually being made, right? And so I think, especially as we kind of transition away from some of the historical reasons why, why we had previous business models before, I think you're going to see a lot more of these cost savings of the type.
Perfect. Well, we're right at time now. So Sid, Dennis, Josh, thank you all so much for coming to this panel. And obviously, thank you for everybody coming. We'll be hanging around here afterwards in case you have any questions. But thanks for listening about AI and scrap industry. And hope you have a great rest of ISRI 2024. Thank you.